Okay, continuing on with section 6.3, we're going to be computing exact values again of the sum and difference identities, but this time we're going to be given information about the trig function ratios, so opposite, adjacent, hypotenuse, and it's very helpful to draw these pictures and find all the trig functions, and then you can just easily plug those right into the cosine, sine, or tangent sum and difference formulas. So if you look at the information that we're given, it says find the exact values of the trig function given, knowing that the sine of alpha is equal to 5/13 and that the cosine of beta is equal to -3/5. And then it tells you alpha and beta are both in quadrant 2. Now, not all of these angles are going to be in the same quadrant, so make sure you pay attention to what that's telling you, because alpha and beta are two separate angles. So I've drawn two different coordinate planes, and let's take a look at alpha. We're going to put alpha on this one. So we're in the second quadrant, and we're just going to roughly sketch out what this looks like. So second quadrant angle, this is alpha, and let's draw in our right triangle so we can label some sides, and we're going to draw this in towards the x-axis, so we're looking at the reference angle, which has the same terminal side. And sine alpha is 5/13. Well, the sine function in right triangle trig is opposite over hypotenuse. So the opposite of our angle here is going to be 5, and our hypotenuse is going to be 13. Well, we can easily use the Pythagorean theorem to figure out what our adjacent side is, or our x side. So let's do that really quick. So we have x squared, I'll label this x, plus 5 squared is equal to 13 squared. So x squared is equal to 169 minus 25. So we have x squared is equal to 144. And when we square root, we have x is equal to plus or minus 12. Well, we know we're in quadrant 2, so that means our x value is going to be -12. And then if we set up our other trig identities, we already know that the sine of alpha, which was given to us as 5/13, cosine of alpha is adjacent over hypotenuse, so that's -12 over 13. And then the tangent of alpha, which is opposite over adjacent, is going to be 5 over -12, or -5/12. Okay, let's take a look at beta. Again, it's a second quadrant angle, so we'll just draw that in. So here is beta. And again, let's draw in our right triangle. Cosine is adjacent over hypotenuse. And when we're drawing these out, our hypotenuse is the radius, so that's always going to be positive. So we know that this is -3/5. So our adjacent side is going to be -3, and our hypotenuse is going to be a +5. And this time what we need to find is y, or our opposite side. So we're going to have -3 squared plus y squared is equal to 5 squared. So we have y squared is equal to 25 minus 9. So y squared is equal to 16. Y is equal to plus or minus 4. And again, since we are in quadrant 2, the y values are positive, so y is equal to +4. And let's set up all of our trig ratios. So we know that the sine of beta is going to be opposite, which is 4 over hypotenuse. Cosine beta was given to us as -3/5. And tangent beta is equal to opposite over adjacent. So there are all of our ratios. Now that's just the setup. Now we're going to look at what they're asking us to find, which in our first example is the cosine of alpha plus beta. Well, that's the cosine sum. So if we go back to our cosine sum identity, that's equal to cosine alpha cosine beta minus sine alpha sine beta. Well, now, since we have all these identities written out, we can just substitute in. So cosine alpha, which is right up here, is -12/13. Cosine beta is right here, is -3/5 minus sine alpha 5/13, sine beta 4/5. Okay, then we just multiply each pair, so we end up with a positive 36/65 minus 20/65. So our final answer for this one is 16/65. That is our exact value.